All right, and we're back. Um, we've been talking a bit about the metric system and how we use that a lot in science. And the way, as I've mentioned, the way that you change the magnitude of a unit in the metric system is by adding or changing the prefix that's used before the name of the unit. This is different from the English system because, for one thing, in the English system, you go to a whole other unit, like ounces to gallons or inches to feet to miles. And in the metric system, you just change the prefix. So you go from millimeters to centimeters to meters to kilometers. It's just a matter of changing the prefix or removing the prefix. Also, in the metric system, when you change the values of the unit by adding or changing or subtracting or taking away a prefix, you're changing the value of the unit by something involving a factor of 10, maybe 10 or 100 or 1,000 or a million. But it's basically just a matter of moving the decimal points around when you're doing unit conversions within the metric system. Within the English system, nothing is based on factors of 10. So you have to go through elaborate mathematics to get, say, from inches to miles. And whereas in the metric system, that kind of thing would actually be pretty easy. The metric system, though, being used in science, it has to be prepared to deal with a very broad range of values from extremely large to extremely small. And so there's a very wide range of metric prefixes available. The book gives a very complete range of metric prefixes, all the way from 10 to the 24th power to 10 to the minus 24th power. And not all of those are very commonly used. I mean, those are there for you to use if you want to, but I'm going to focus on some of the ones that are more commonly used. So that'll basically cut out a couple on the top end and the bottom end. You don't have to memorize these because you will have that conversion factor sheet that I handed out at the beginning of the semester to use on all of the tests. And on quizzes, since they're take home, you could always look in the book if you need the value of the metric prefix. But you should be familiar with them anyway, and definitely should know how to use them. So being a prefix, what it means is that the metric prefix is affixed before the name of the metric unit. Like we've already seen with things like millimeters. A millimeter would be 1/1000th of a meter. Or kilometers, a kilometer would be 1,000 meters. So the word that changes the value of the unit comes before the name of the unit. And if you see the name of the unit without a prefix on it, then that just means one of the base unit. So the top one that we really need to be concerned about would be peta. The abbreviation for that, or the symbol for that, is capital P, followed by the abbreviation for the base unit. So like petameters would be capital P, lowercase m. And the value of that would be 10 to the 15th. 10 to the 15th is 1 quadrillion, if you really want to know. Tera is symbolized by a capital T followed by the symbol of the base unit. That one you may actually have heard of because it's used in computing a lot for like terabytes of storage capacity, for instance. And that is a trillion of something. Okay, so that's tera. Giga is next. Capital G is the symbol, and that would be 10 to the 9th. or 1 billion units. Mega being next is capital M, and that would be 10 to the 6th or 1 million. And then kilo, and that's a lowercase k actually, and that stands for 1,000 or 10 to the 3rd. There are also prefixes that stand for a lot of the numbers between these numbers that we're, notice we basically skip by a factor of 1,000 down to this point. There are prefixes that stand for the numbers in between, but those are hardly ever used, so we're not going to bother with those. And even though I am going to mention it, I'm going to put it in parentheses because this one is hardly ever used either. Hecto, which is a lowercase h, stands for 100 of something. Although I can't remember actually ever encountering that. Same with deca, which has the symbol DA, and that stands for 10 of something. So since we're going by factors of 10, we're now down to the base unit. And the base unit stands for 10 to the 0 power of the units, or in other words, 1. Because remember, any number to the 0 power is 1. So the base unit is just 1. A meter is just 1 meter. A liter is just 1 liter, and so on. Anything below the line here is going to be less than 1. So we're getting into fractional values now. Deci, or just lowercase d followed by the abbreviation of the unit, is 1/10, or 10 to the minus 1, or 0.1, depending on how you want to look at it. Okay, centi, which is lowercase c as a symbol, that's 10 to the minus 2, or 10 to the 100th, or 0.01. And milli, which is a lowercase m as the symbol, and that's 10 to the minus 3, or 1/1000, or 0.001. And then we start skipping by factors of 3 again, because we don't encounter values in between as often. So the next one of importance is micro. Uh-oh. What do we use for the symbol for micro? We use capital M up here and lowercase m down here. They kind of back themselves up into a corner here, so they actually had to resort to the Greek alphabet. And in the Greek alphabet, the letter that is equivalent to our M is called the letter mu. And it turns out that a capital letter mu looks exactly like a capital M, so that was out. The lowercase mu, though, looks a little different. It looks like a U with a tail on the front of it, like that. And so they decided to use that as the symbol for micro, the letter mu. you can kind of see if you compare this to the way I made the capital M up here, you can kind of see how that eventually over the years developed into RM, but it took a while. But anyway, it's you can think of it as a U with a tail in front, and that means micro. Micro is 10 to the minus 6, or 1/millionth of a unit. The next one, again, is a factor of 3. The next one of significance is nano. Lowercase n. That is 1/billionth, or 10 to the minus 9 of a unit. Then we have pico, which is a lowercase p for the symbol. That's 10 to the minus 12. That's a trillionth. We just can't help ourselves in science. We keep improving our methods more and more, which necessitates the development of even smaller and smaller metric prefixes. So we got femto, which is a lowercase f for the symbol, 10 to the minus 15th. Or 1/quadrillionth. And of course, as we see in the book, it goes even beyond that. But we'll leave it for there because these are the commonly encountered ones. The metric prefixes, again, can be used in unit conversions by using the name or symbols of the prefix along with the units and along with their values in order to accomplish a unit conversion. Just a quick example of how you can do that, and we'll go over some more unit conversions later to sort of, show how they can be done and get in the habit of using conversion factors. Well, we could just look at, say, for example, the diameter of a baseball is 75 millimeters. What would that be in meters? So what you can do is take the number that you begin with and find the relationship between that unit and the unit that you want to end up with. In this case, both units are within the metric system, so all you really have to do is know the values of the metric prefixes. And fortunately, one of the units has a prefix and the other one doesn't. That makes things easy. That usually means that you can probably do this conversion in one step because all you need to know is the value of the prefix milli. Setting up the calculation, you start with the number you're given. You multiply it by some conversion factor. And you end up with the number you want and the units you want. We know in this case that the units we want are meters. We know that we've started out with millimeters. The conversion factor needs to be the relationship between millimeters and meters. We know from up here that millimeters, 1 millimeter is 10 to the minus 3 meters. One question might be which number goes on top and which goes on the bottom, 1 millimeter or 10 to the minus 3 meters, sorry. Well, look at the units that you're starting with and the units you want to end up with. If you're starting with millimeters, that means you want millimeters to cancel out. When you're starting with a number that's just on its own like that, that's equivalent to being in the numerator. So you want that unit to be in the denominator in the conversion factor so it will cancel out with the unit in the numerator that you're starting out with. So you want millimeters in the conversion factor to be on the bottom. We want to end up with meters in the numerator of the answer, which means meters should be in the numerator of the conversion factor. So this decides, which quantity goes where, and now you just have to fill in the numbers. It's 1 millimeter for every 10 to the minus 3 meters. Okay, or 10 to the minus 3 meters for every 1 millimeter. Now we see that the units millimeters will cancel out, and 75 times 10 to the minus 3 would be 0.075 meters. So that's how you can use the values of the metric prefixes to do unit conversions. Whoops. Okay, suppose we wanted to know what is the diameter of the baseball in kilometers. Well, actually, now that we've got it in meters, that would be pretty easy because you would be going from a unit with no prefix to a unit with a prefix. So again, all you have to know is the value of the prefix kilo in this case. Okay, so we've got 0.075 meters times your conversion factor, and that will give us a unit that hopefully will end up being with kilometers in the numerator. We need the relationship up here between kilometers and meters. So 1 kilometer is 1,000 meters. But where do they go? Well, again, you're starting with meters here in the numerator, so you want meters in the denominator of the conversion factor. You want to end up with kilometers in the numerator of the answer, so you want kilometers in the numerator of the conversion factor. So there you go. Now you just have to fill the numbers in, and you can come back to the table for the numbers. 1 kilometer is 1,000 meters. Okay, so meters will cancel out. 0.075 divided by 1,000 would be 0.00075 kilometers. One thing you can often do during unit conversions is to look at the final answer, and although you may not know if it's correct exactly, you can at least, in many cases, determine whether it makes sense or not. For instance, if you're doing a simple conversion like this with units of length, if the unit gets bigger, the number should get smaller because you're measuring the same quantity just in different units. So the size of the quantity that's being measured is remaining the same. So if the units get bigger, the number has to get smaller to compensate for the units getting bigger, and vice versa. If the units get smaller, the number gets bigger. It's kind of like going from inches to feet. When you go from inches to feet, the unit's getting bigger, so the number gets smaller. 12 inches would be equal to 1 foot. So the number of inches is greater than the number of feet because feet are bigger than inches. Same idea here. If you're going from millimeters to meters, the unit is getting bigger, and therefore the number should get smaller. And it did. Went from 75 to 0.075. So that's quite a bit smaller. Same idea in the second example. You went from meters to kilometers or kilometers. The unit got quite a bit bigger, so the number should get quite a bit smaller. And it did. So you can at least tell that it makes sense, even if you don't know whether you got exactly the right answer. Another one, let's see. So say, for example, actually there are a lot of units that are considered metric units beyond the ones that we've mentioned so far. So there are units like, for instance, watts, which is a unit of electrical power. And the most common place that it's used is for like measuring or rating light bulbs. You know, the power of a light bulb, how bright it is, can be related to the electrical power, which is measured in watts. Well, watts actually is a metric unit, and you can use metric prefixes with watts. So if you have a light bulb that has a power rating of 40 watts, what would that be in megawatts? Capital M followed by capital W. Capital W is the symbol for watts. Capital M, capital W would be megawatts. So what would that be in megawatts? Let's see, 40 watts times a conversion factor, and we want megawatts. 40 watts is considered to be in the numerator, as is the megawatts. And again, we are going from a metric unit with no prefix, like watts, to a metric unit with a prefix, like megawatts. And that means that we need only one conversion factor, and we can get it from the table here. 1 mega unit is equal to 1 million of the base units. So in this case, 1 megawatt is equal to 1 million watts. Okay. Okay, so we have this. 1 megawatt is equal to 1 million watts. And then we just have to decide which side of the equation goes on top and which goes on the bottom. Watts is in the numerator for what we're starting out with, so we want watts to be in the denominator in the conversion factor, so it'll cancel out. We want to end up with megawatts in the numerator, and so we put megawatts in the numerator of the conversion factor, and it's 1 megawatt for every million watts. Okay, so this is going to be 40 divided by 10 to the 6th. It's going to have a lot of zeros in it, so I'm going to get my old calculator out here. Okay, so that's going to be 0.00004 megawatts. Or 4 times 10 to the minus 5 if you want to do it in scientific notation. We'll do scientific notation a little bit later. On a calculator, in case you're using a scientific calculator for the first time, this here is the most common type used now. And to do something like this, say 40 divided by 10 to the 6th, you would just put in 40 divided by, and 10 to the 6th power can be written as, can be entered into the computer or calculator as 10 raised to, the little up arrow there is raising a number to a power. So 10 raised to the 6th power, and then you hit equals or enter, and you get your answer out right there. All right. So that's what you should end up with. Again, megawatts are bigger than watts. So you, the unit got bigger, started with watts, ended up with megawatts. The number should get smaller. And whoa, it definitely got smaller. Okay, so that's just a quick example of unit conversions with metric prefixes. We'll go over harder ones later on, ones that where maybe both of the numbers have prefixes, ones where you might have a number or a measurement on the top of a fraction and the bottom of a fraction that both have to be converted, fun stuff like that in a little while. First, I want to get to scientific notation and to make sure everybody's familiar with that. and also get into the idea of significant figures and rounding off. But I see we're coming pretty close to the end of this segment of the lecture, which is the last one. So we're going to have to save that further information for our second lecture of the week, which will be out sometime after Wednesday. Okay, so I'll see you then. Bye.